So, you know how search works, right? You type in some words, you get back some links. But what if you could search for a feeling or a complex idea and get back not just text, but the perfect image, the right video clip, maybe even a relevant article? Well, that's not science fiction anymore. That's the world of multimodal AI, and it's all about moving way beyond simple keywords into the realm of, well, true understanding.
But that raises a huge question, right? How in the world does an AI do that? How does it look at a sentence, just a string of words, and then go find a specific image that matches it? I mean, we're talking about bridging the gap between the abstract world of language and the very concrete world of pixels. And that's the core challenge we're going to unpack right now.
All right, so let's get into it, the multimodal search challenge. To really get why this new stuff is such a big deal, you gotta understand how things used to work. For, like, forever, search has been completely siloed, stuck in these separate little boxes.
Okay, think about it like this. Your old school search engine, it's pretty good at matching text with text, or finding images that look like other images. But it doesn't understand anything. So you could search for office humor, and it'll find articles with those words. But it has no clue what sarcasm is. It can't look at a funny office comic and get the joke. It's missing that deeper conceptual connection. And that's exactly the gap we're trying to close here.
So how do we solve this? Well, it's a two-step process. Let's start with step 1, fast retrieval. The first part of the solution is all about casting a super wide net and doing it incredibly fast across all kinds of data. And the technology that makes this possible is something called an embedding model. Now, this is the key. Think of it like a universal translator, but for concepts. It can take literally anything, a picture, a sentence, a video clip, you name it, and turn it into a unique numerical fingerprint. And this fingerprint isn't random. It actually captures the core meaning, the whole vibe of that piece of content.
And because everything gets turned into this same kind of numerical fingerprint, you can suddenly compare anything to anything else. An idea in English text can be compared to a photo. A screenshot can be compared to a video clip. It works across more than 30 languages. This thing is built for pure speed and massive scale. But there's a catch. Casting a wide net is great, but sometimes you catch stuff you don't want. Speed is awesome, but it's not the whole story.
And that brings us to step 2, pinpoint accuracy. Because for a truly smart system, you need more than just speed. You need precision. This is where we go from finding a bunch of plausible results to finding the perfect one. And for that, we use a totally different kind of tool, the re-ranker model. This thing is a specialist. It works completely differently. Instead of just comparing two separate fingerprints from a distance, it takes the search query and a potential result and looks at them together, side by side. It does a deep, deep analysis of the pair, which lets it pick up on all the nuance and subtle context. And the output? A super precise relevant score.
So, let's put it all together. You've got two models with two very different jobs. The embedding model is your broad sweep. It's fast, it covers a lot of ground, and its goal is just to get a list of decent candidates. Then you have the re-ranker. That's your fine-toothed comb. Its job is to go through that shortlist with extreme care to find the absolute best result. They're a perfect team. So let's see how they actually work together in a real system. Okay, this is where the magic really happens, the production-grade pipeline. Because neither of these models is enough on its own. It's how you combine them that creates something truly powerful.
So here's the two-stage process. First, stage 1, fast retrieval. The embedding model blasts through millions of items and, in a fraction of a second, pulls out maybe the top 100 most likely matches. It does all the heavy lifting up front. Then, and only then, we move to stage 2, precise re-ranking. The re-ranker model takes that small, manageable list of 100 candidates and gives them its full attention, meticulously examining each one to resort them for perfect relevance. And just to be super clear, this isn't some theoretical idea. This two-stage pipeline is the absolute gold standard. If you want to build a state-of-the-art, production-grade search system today, this is how you do it. Fast retrieval first, then precise re-ranking. That's the architecture.
All right, enough with the theory. Let's see this thing in action. We're going to put the system to work and see just how intelligent it really is with a couple of real-world examples.
Okay, for our first test, we're going to focus just on the re-ranker's precision. Our query is a combo, a sarcastic office image plus the text, funny office comic. The goal here is simple. Can it tell the difference between stuff that's actually relevant and stuff that's just kinda, sorta in the same ballpark?
And wow, look at these results. It's pretty incredible. The documents that are genuinely about office life, they get scores of 0.99 and 0.98, basically perfect. But then look at the other stuff. A document about deep learning, score 0.23. Something about cooking, 0.10. It's not just ranking them lower, it's confidently saying, nope, this is not what you're looking for. This is that deep contextual understanding we were talking about.
Okay, that was just the re-ranker. Now for the main event. Let's test the full two-stage pipeline. This time, our query is just a single image, this picture of a shocked family looking at a screen. We're going to search a whole database that has both images and text documents and see what happens.
So, here are the results from stage 1, the fast retrieval step. The embedding model does its thing. And the top results are pretty much what you'd expect. The exact image is number 1, a few other visually similar photos are in there too. But look closely at number 4. It's a piece of text, people showing shocked expression. The model found a semantic connection, but it buried it down in 4th place. Not bad, but not perfect.
But now, watch this. The re-ranker takes over. It analyzes that short list and boom! The final ranking is completely different. That text description, people showing shocked expression, jumps all the way from 4th place to the number 1 spot. This is it. This is the proof. The system didn't just match similar-looking pictures. It understood the meaning of the image and found the text that perfectly described it.
And this isn't just a couple of cherry-picked examples. This kind of performance holds up under pressure. We're talking about rigorous, industry-standard benchmarks that are designed specifically to test this kind of deep, multimodal understanding. And on one of the toughest, most comprehensive benchmarks out there, the AP parameter version of this model hits a score of 77.8.
Now, a number is just a number, but what that 77.8 means is huge. It's a new state of the art. This system doesn't just compete with, it outperforms the previous best-in-class models. It literally sets a new benchmark for what AI can do when it comes to understanding content across different formats.
So let's wrap this up with the key things to remember. First, AI search isn't about keywords anymore. It's about meaning. It can search across text, images, and video all at once. Second, that two-stage pipeline, the fast embedding model plus the precise re-ranker model, that's the magic formula. It's the gold standard for getting top performance. And finally, what this all adds up to is a much deeper, more human-like way to search and find information, no matter what it is.
Ultimately, what we're really seeing here is a fundamental shift. This isn't just about processing data anymore. These systems are starting to understand context, nuance, and meaning in a way that feels a lot like our own human intuition. The line between how we understand the world and how AI understands it, yeah, that line is getting blurrier every single day.